Formal analysis of a game or gameplay is the process of systematically breaking down a game into its component parts, describing those parts and how they relate to one another in detail, and explaining how they contribute to the overall game system. Conducting a formal analysis of a game or its gameplay provides a structured, consistent way for researchers to examine and discuss game components and rules. A well-executed analysis ensures that any researcher can produce the same results, creating a reliable map of game structures for further study. There are several methods of formal analysis, but in this video, I will be describing Lankoski and Bjork's framework as described in their 2015 Game Research Methods text. Let's start by identifying the basic units of a game. The smallest building blocks of a design are referred to as primitives, and there are several types of primitives in game design. 1. Components. These are objects in a game that players or the game system can manipulate. In board games, components include things like the board, tokens, and cards. In digital games, they include characters, objects, platforms, and enemies. Components also have attributes, variables and characteristics that can sometimes change throughout the game. As an example, let's look at this screenshot of the classic Nintendo game Super Mario Bros. The components on this screen include Mario, the hammer the enemy is throwing, and the environment's bricks, platforms, and pipes. Mario has the attributes large and fiery because he previously touched the fire flower component, which gives him the ability to shoot fireballs. Mario can lose the attributes large and fiery if he is hit by an enemy. 2. Actions. Actions refer to the behaviors that players or the game system can perform. These include rolling dice, drawing cards, moving a character, choosing dialogue options, etc. Essentially, anything you or the game system can do is considered an action. Action primitives can be further divided into player and system actions. Player actions refer to actions players can take and generally represent what the player can choose to do in the game. System actions are behaviors that the algorithm of the game can execute. Looking again at this Super Mario Bros. Screenshot, we can see several player actions taking place. Mario is running, jumping, and shooting a fireball. The game system is also performing actions, like spawning the enemy, moving it, and making it jump and throw hammers. Note the game system is also running the timer down in the upper right-hand corner. 3. Goals. Goals define the conditions for progress and success in a game. They guide what players work toward, often leading to progression or the game's conclusion. Completing a series of goals, including a final goal, typically determines the victory conditions, what players must do to win. The Super Mario game is structured around a series of short-term goals, such as reaching the flag or axe at the end of each level without being hit by enemies or falling into pits. The player progresses by completing these goals, ultimately reaching the final axe and clearing the final level, which represents the game's ultimate victory condition. One final term that is important to define is game state. In game studies and game theory, the game state refers to the exact status of all components in a game, including their positions, attributes, and all relevant information about the game's characteristics at a specific moment. So in the context of the Super Mario game, this screenshot is a moment in time with a specific game state. The location of Mario on the stage, the power-up he has, the location of obstacles, monsters, and projectiles, the lives Mario has remaining, the score, and time remaining on the clock, etc. These elements make up the game's state at this particular moment. A strong formal analysis should ensure that different researchers or designers would identify the same game primitives and describe them consistently. The goal is to provide an accurate and complete description of the game so that any researcher analyzing the game can clearly and consistently explain what happens in the game and how the player and the game interact. Lankoski and Bjork outline 3 levels of gameplay description for conducting a formal analysis of gameplay. 1. Describing primitives and their relationships. 2. Describing principles of design. And 3. Describing the role of primitives and design principles in the game. The first level, describing components, actions, and goals, is necessary for understanding the broader role of these primitives in the game. For instance, understanding the principles of design, a level 2 description, and the role of the elements in a game, a level 3 description, depends on first describing the primitives and their relationships. In my next video, we'll explore a specific game through the lens of game-based learning. We'll examine a STEM concept modeled in the game, perform a formal analysis of that part of the game, and I'll share real examples from my research on the learning we observed using these tools. Make sure you're subscribed to our channel so you don't miss it.